Your Academic Skills Center presents this video series to help you strengthen your statistics skills.
Hello STAT students, and welcome to the Multiple Linear Regression video presentation. My name is Janine Allwright, and I'm the Instructional Specialist at Walden's Academic Skills Center, where I lead the Statistics Tutoring team. In this video presentation, we will firmly engage with the Multiple Linear Regression test. I will explain that we're still working with a limited sample data set to answer a research question about the greater population, and we will discuss research questions and hypotheses that pertain to this specific test. I will briefly discuss the assumptions and set up an example for you in SPSS and show you how exactly to run this test. I will then interpret the test results at model level first, followed by a variable level interpretation, and I will review the output tables with you to show you which numbers are important for your APA write-up. Of course, I will tell the story of the data and engage with the social change interpretation as well. Now let's get started. If you have viewed other videos in this video series, then surely you are familiar with this figure here on the screen that shows the connection between the limited sample and the population. In this video, we will use the multiple linear regression test to make that connection and test our sample data against a 95% confidence level to answer the question about the greater population. A research question for a multiple linear regression model follows the approach that we started on the earlier video, the bivariate linear regression, where our research question incorporated words like effect, impact, influence, and so on. In this example on the screen, I'm evaluating whether two independent variables, grant funding and committee work, influence the number of publications in higher education. I start my research questions with the phrase "to what extent," and I've explained to you on an earlier video that that is what I learned when I worked on my dissertation, and that was the preference that my chair had. I recommend that you engage with your instructor in the classroom to learn what your instructor's approach is to research questions and hypotheses. I'm going to translate my research question into an alternative hypothesis first to show what I'm expecting to find. I'm expecting that grant funding and committee work will affect the number of publications in higher education, and my null hypothesis will deny that. Now, some instructors might ask you to set up a set of hypotheses for each independent variable on the dependent variable as well, for an individual inside of that independent variable, but I will not engage in that approach. I will use only the combined approach here. Both independent variables are used in the research question, as is the dependent variable, and I'm exercising IV before DV here. Of course, our multiple linear regression test comes with its own list of assumptions, but the assumption test is handled differently here. We will provide the assumption test in one comprehensive model diagnostic after we have interpreted the full results of the model to evaluate that relationship between the independent variables and the dependent variables. And when we think about assumptions in the multiple linear regression environment, we think about outliers that can be an influencer. Lack of autocorrelation can be a problem. Of course, multicollinearity is that relationship between the independent variables that can disturb a model. Errors ought to be normally distributed, and that is also an assumption we will test for. We'll test for the error variance and the existence of linear relationships, as in every independent variable needs to have a relationship with the dependent variable that is linear. These assumptions will not be addressed as part of this video presentation, but will be offered in a future video when we test the assumptions in a comprehensive model diagnostic. The multiple linear regression in SPSS is set up with two independent variables that are scale, a dependent variable that is scale, And we will click the descriptive box for good measure so that we have the information about the behavior of the independent variables, but clicking the descriptive box will also generate that correlation matrix. We will interpret the results at model and at variable level. Now, of course, the model level comes first, and that is followed by the variable level at coefficient box. But at model level, we're going to first check the correlations to see if there is a relationship between each independent variable and the dependent variable. We will then evaluate the significance and our null hypothesis, and that p-value is found in the ANOVA box. If significance is confirmed, we will report the effect size, and for this test, that is called the adjusted R-square. At variable level, we're going to look at the significance of each variable. If variables are significant, they will be further interpreted with the unstandardized beta to learn what their pull or push is on that dependent variable. And we will also interpret the standardized beta. And now we can compare the variables because we have taken that unit effect out of it, and we can compare them for how strongly they work on that dependent variable. That is an important question to ask for the social change interpretation. I have a specific data set here ready for you that is a continuation of the data set that I used in the previous video on correlation and bivariate linear regression. And as you can see here, I have my variables here. I have three scale variables. I'm going to predict how many publications are produced by any person that works in higher ed based on the grant funding and committee work. In other words, can you predict somebody's output when it comes to publications based on how much grant money they bring in and how much committee work that they fulfill? One would assume that if you get more grant funding, you are probably going to publish more, because that's often a requirement for grant funding, that you publish your research. And then committee work could work against it. If you're busy with committee work, you're not spending that time doing research, and that's an interesting regression. And to that end, let's take another look at the research question that we formulated earlier. To what extent do grant funding and committee work affect the number of publications in higher education? And that will lead me to the alternative hypothesis, the one that I'm expecting. I'm expecting that yes, these variables affect the dependent variable, and of course the null hypothesis will deny that. And we can now return to SPSS and run the test. And for that, I'm going to bring up the regression option here under the Analyze button. And as I mentioned on an earlier video, there's no need to run the correlation separately. It can be incorporated in the regression setup. Linear regression. My dependent variable is the number of publications, and I'm going to bring my grant funding and committee work over. Those are my two independent variables that are both scale. And because I'm not going to evaluate any statistics that pertain to the diagnostics of this model, I will only ask for the descriptive function here. But just because I am not presenting the assumptions with this test at this moment, that does not mean that you can skip the assumptions altogether. I am just moving that part to a different video presentation. I recommend that you check with your instructor what kind of assumptions are needed and if that can be included in a diagnostic of the model, and which assumptions the professor would wish to be tested. Now I can click OK on the test setup here, and here is my output. First, I'm going to interpret the variables here, of course, as we always do. I have the descriptive statistics for my three variables, and I surely want to describe them to my readers. The number of publications on average on this data set is 5.83 with a standard deviation of 8.1, and my sample size is 124. I can discuss grant funding and committee work as well in the same manner. Please introduce the variables to your reader, as your reader is not yet familiar with this data set. Now I'm going to glance over my Pearson's correlation. Here are my Pearson's correlation values, but here are my sinks. I'm hoping for significant relationships between each independent variable and the dependent variable. I'm going to move my mouse horizontally to where the one variable meets the other. The relationship between grant funding and number of publications is significant. And the second independent variable, committee work and number of publications, is also significant. I have a relationship somewhat at the 0.05 between grant funding and committee work. So there's definitely some kind of a relationship between my two independent variables. But when I click on this number, I can see that it's probably going to be a little bit, oh, it's smaller than 0.05, so it is significant. See, that's good to look at. Now, at this moment, I'm not going to comment on that because in the multiple linear regression, we have a larger look on the model, but at this moment, I will put up a tiny little red flag for myself, knowing that if something goes wrong with this model, this might be the reason. The two independent variables have a relationship that takes away from what they can bring to the dependent variable. It is something to keep in mind for the further interpretation of this model. I'm going to bring up the slide that shows the interpretation at model level. And that is, one moment, that is this slide. So I'm going to check the correlations, which I just did. Now let's evaluate significance and effect size. And my significance from my null hypothesis is evaluated by comparing this p-value to 0.05, the alpha. And this is significant, so my two predictors can predict the dependent variable. So number of publications can be predicted with the committee work and grant funding. And I can now interpret the effect size of the model. I'm going to my adjusted R-square. I'm multiplying that with 100. 14.2% of the variability of the dependent variable is explained with the combination of the two independent variables. I have the definition for the R-square interpretation on a slide here, and I'll share that with you. I multiplied with 100%, and that tells me how much percentage, what percentage of the variance of the dependent variable is explained or predicted with or by the independent variables. I have multiple variables in this regression model. I have now interpreted this at a model level. I want to now move back to the slide with the interpretation at variable level. First, I'm going to interpret the significance, and then if a variable is significant, I will interpret the unstandardized and standardized beta. Let's bring those values up. At coefficient level, I can see that they are both significant. Grant funding has a p-value smaller than 0.05, and so does committee work. So both variables bring something to the regression equation. I can interpret both separately to evaluate how much variance of the dependent variable is explained by grant funding while holding the other variable constant. Careful, when you interpret more than one variable, you have to add that piece to it because that is the flushed out effect of the one variable on the dependent variable while the other one is being held constant. And it sounds like this. If grant funding goes up with 1 unit, which turns out to be $10,000, if grant funding goes up with $10,000, the number of publications goes up with 1.056. So indeed, while holding committee work constant. If my committee work goes up with 1 unit, the number of publications goes down with 0.788. Note the minus sign there, while holding grant funding constant. I cannot neglect the other variables. They play a part in the regression equation, but if I interpret them one by one with the unstandardized coefficient, I have to note that I'm keeping the other variables constant. Now, lastly, the standardized coefficients come into play here. I cannot compare the unstandardized coefficients because they're both measured at a different scale. I don't know what the unit is. Committee work, maybe it's measured in hours. I would assume so. Grant funding is measured in $10,000 per unit. I can't compare that. That will create an apple to oranges situation. I can move to the standardized betas, and the standardized betas show me exactly what the betas are if we take the unit effect out of it. And I'm going to interpret that in its absolute. I can now see that grant funding has a stronger push on the dependent variable than committee work. Forget that committee work drives it down. Yes, it is a negative relationship, but if I want to compare them, I will compare them in their absolutes. 0.328 is larger than 0.178, indicating that there is a harder push against that number of publications. So if I want to make a positive social change, I would encourage anybody working in higher ed to engage with grant funding. And then secondary, you might want to limit your committee work some as well, but it's the second factor. And with this last part, I'm ready to write up the regression equation. And we know from the previous video that the regression equation information comes from this part of the table. And I will definitely engage that when I review the tables with you. And that is the last part that is still standing here for me, is the review of the tables, and with that also the review of the social change implications for these results. Let's take another look at the tables on a slide, much like I presented to you in previous videos. Here are the exact tables from SPSS that I've copied in here for you. And you can see here that we use the descriptive statistics to give that sample description of the variables. Please do your reader a favor and introduce these variables, because you have to assume that your reader is not familiar with your data set. I want to take a look at the correlations to see if there are linear relationships between each IV and DV. But I also want to evaluate if there is a relationship between my two IVs. Are these IVs having a relationship together that might take away from the relationship that they each have with the dependent variable? And here are my two significance values for the IV and the DV. But I also see a significant relationship here for the IVs together. And that's worrisome. But it's not a stop moment, it's a moment that you want to keep in mind. At model level, I'm going to evaluate the sig first to evaluate my null hypothesis. I can clearly reject my null hypothesis as p is smaller than alpha, which allows me to interpret the effect size. I multiply that with 100, and that tells me exactly how much of the variability of my dependent variable is explained by the combination of the two independent variables. These numbers are slightly different from what I had on SPSS, but it's in the same line, 9.7%. I like to also see the opposite of that, 9.7%. So I could easily take 100 and subtract 9.7%, and I get 90.3% of the variability of the dependent variable is contributed by other factors. That part has a good social change interpretation, because even though I find a relationship between committee work and grant funding and number of publications, there are of course other reasons at play here that influence how much somebody in an academic environment will produce in publications, and they require some insight as well. Now, when I write this up, I would need the degrees of freedom and the F value for APA write-ups. And then we will also take a look at the interpretation at variable level. I'm going to look at the coefficients table, because that's where the variable level information lives. both significances, both p-values have to be individually addressed and interpreted for significance. Just because a variable is entered into the regression equation doesn't mean that it's always going to be a situation where all variables are significant. Sometimes variables drop off. If variables drop off because of a p-value that's greater than 0.05, that's all you can say about them. You do not interpret them further. Let's move on to the unstandardized coefficients for both variables. I can see that for every unit of committee work that I bring, the dependent variable goes down with almost 1, minus 0.852. Grant funding, on the other hand, goes up for every additional $10,000. I increase my publications with almost 0.8. So there's one positive relationship at work here, and there's one negative relationship at work. I cannot compare them under the unstandardized coefficient column, but I may compare them when I standardize them. When I take the unit effect out of them, then I can compare the 0.247 and the minus 192, and I can see that in its absolute, ignore the negative sign, I can compare 0.247 and 0.192 and conclude that grant funding is a stronger predictor for number of publications, while holding the other variable constant. If you want to encourage people that work in higher ed to publish more, produce more publications in a year, then encourage them to engage with grant funding. It seems to be a real motivator behind publications, more so than committee work. And there's your social change. If you want to encourage that positive social change, then you focus on that variable that produces the highest result. Now, lastly, I would want to write out my regression equation. And while I was able to produce a nice graph with two variables for that linear regression video presentation, I do not get to do that here because I have too many variables on the independent side. There's no place to put them all. So I'm going to evaluate my numbers and use that to write up the equation. I know that my dependent variable equals the constant, 5.092. I'm going to add up the factor that I'm going to multiply my independent variable with, 0.789, and I'm going to, in this case, subtract the 0.852, that negative number that I'm going to use as the multiplier for the IV2. I want to encourage you to write up your regression equation because it also gives you that viewpoint that all independent variables lie on the right side, all the dependent variables lie on the left side. It helps to illustrate what's really going on here and what the story of the data is. If I know the grant funding and committee work of any person that works in higher ed, I can calculate how many publications they produce a year. Apparently, everybody starts off with at least 5 publications a year. And with this last mention of the equation and the interpretation of the full regression model, our multiple linear regression video presentation has now come to an end.
Thank you for watching this video presentation. If you have course-level statistics questions, reach out to our stats tutors at statsupport@mail.waldenu.edu or view our statistics support resources at academicskills.waldenu.edu.